Hello everyone. Thank you for your patience and welcome to the webinar titled Using Oracle's Data Management Workbench to Optimize the Management of Clinical Data from InForm and Other Sources, presented by BioPharm's Mike Grossman, Vice President of Clinical Data Warehousing and Analytics. I'm Eugene Stepanoff, the Marketing Manager at BioPharm, and I'll be going over some housekeeping items before I turn it over to Mike. During the presentation, all participants will be in listen-only mode. However, you may submit questions to the speaker at any time today by typing them in the chat feature, which is located on the left side of your screen. Please make sure you state your questions clearly. Keep in mind, other webinar participants will not see your questions or comments. Nonetheless, your questions to the speaker will be addressed as time allows. If you still have unanswered questions after the webinar or would like to request information from BioPharm, feel free to visit the company's website for contact information. As a reminder, today's webinar is being recorded and will be posted on BioPharm's website within 24 hours. We will also be emailing you links to the recording as well as a PDF version of the presentation. This concludes our housekeeping items. I would now like to turn the call over to Mike Grossman.
Thank you very much, Eugene, and thank you everybody for joining the call. I really appreciate it. Today we're going to go through just a few slides and I'll do some introductions. But the vast majority of the webinar will be a live demonstration, so it should be interesting. First of all, my name is Mike Grossman. I run the Data Warehousing and Analytics Group at BioPharm. I've been at this for about 4 years. Prior to that, I spent 10 years at Oracle, and I've spent quite a long time in the industry, both in data management and in the IT side, as well as doing warehousing. So let's just briefly review the agenda. The first thing I'm talking about is a little bit, just a very short discussion about why DMW, why does it exist? And then I'm going to go into how do you set up the Data Management Workbench, and then how do you conduct trials with the Data Management Workbench. So basically a setup phase and then the actual conduct phase. So a little bit about why we want to use a tool like a Data Management Workbench. Really it comes down to each data, such as we collect with InForm, collects much of the clinical data that we need, but it doesn't collect all the clinical data that we need for a clinical trial. And we'd really like to be able to clean the data and review the data ongoing, not just the EDC data, but all of the data. So various companies are dealing with this in different ways. Some people are taking data such as central lab data and they're importing it into the EDC system. Others are pulling the data out of the EDC system and doing manual comparison. And really, Data Management Workbench is really trying to address this whole data review, data cleaning, and data reconciliation process to encompass not just the EC data, but all the data involved with a clinical trial. In addition, it's also trying to handle the ability to transform the data to a common standard so that it can be pooled with other data and you can do a cross-study analysis and ad hoc analysis. Why does this exist? Well, we're really just trying to increase productivity. It's just too labor-intensive to do study-specific approaches here and to handle multiple systems and manual processes. We'd like to have an end-to-end traceable process for all the clinical data from the collect capture, independent of the source of data capture, right through to reporting and analysis. Architecturally, the Data Management Workbench is built on top of the Life Sciences Data Hub. The data that's put in there, the Life Sciences Data Hub is really designed to get a holistic view of all your clinical and metrics data in a single scalable environment that's regulatory compliant. So the Data Management Workbench is essentially a business-specific layer that sits on top of the Life Sciences Data Hub that supports this data capture, data standardization, and data validation step. But because it's built on top of of an enterprise architecture, an application that's designed for enterprise architecture, all the downstream functions such as data pooling, analysis, data review, warehousing, metrics warehouses, all of that data that's coming in through Data Management Workbench is part of that enterprise architecture. So you don't really need a different solution for that architecture. Okay, so what's the philosophy behind Data Management Workbench? Well, it's looking at a process where you load data from your EDC system, and in this case, in this release, it's really focused on Oracle's InForm product. So you load data from InForm and metadata from InForm, and then you load other data. It could be central lab data. In the use case example I'm going to be walking through, it's central lab data, but it could be derived genomics data. It could be adjudication data. It could be any other kind of data that you don't necessarily want to enter into your EDC system because the sites themselves are not directly involved with that data capture. So that data comes in, and you have an opportunity to look at the raw data model, or you can have other data models. So you can transform that data to review data model, a data cleaning model. You could even have an analysis model that is multi-stage processing. So all of this is available conceptually inside of Life Sciences Data Hub, but DMW gives an alternate interface that's a little bit more user-friendly, helps you write the transformations, as you will see. Okay. So one of the basic concepts of the Data Management Workbench is there is something called a study. And this study really correlates to an InForm study. So what we really want to do is a study consists of one or more clinical data models. It includes mappings and transformation programs to move from one data model to the next data model. It includes edit check programs that validate the data. Now you will have edit check programs already in InForm. This is really to do cross-edit checks between the central lab data or the loaded data and the InForm data. And then there's also custom listings as well as default listings that actually help you review the data and track the review of the data. Just go on one more. Okay, so I'm going to stop at the slides right now, and then I'm going to share my desktop, so hopefully this works very well, and we will take a look at the applications themselves. So hopefully you can see my desktop. I basically have a browser. I'm currently looking at the InForm 6.0 application, and we have an example study called Cardio. And I'm just going to do a quick review of this study. So in this study, we've got lots of sites. I'm looking at site number 14 here. We've got patients within those sites. If I click on a patient, you can see the normal InForm matrix. If I go to the form view, we can look at things like the ECG strep. And then this is just a normal interface that you would expect with InForm 6.0. So there's nothing special here. I just wanted to kind of set the stage for the study that we're going to be working with in this example. So you can see we've got lots of visits, lots of forms. You can do data entry, normal study. The second application I want to look at, and the main application we're going to be looking at, is the Data Management Workbench. And this is the interface for the Data Management Workbench, and I'm going to go through this in some detail. And then the third application that we're going to be looking at is the Life Sciences Data Hub. So we'll get an opportunity to see how the Data Management Workbench and the Life Sciences Data Hub interact with each other. So that's really what we're going to be taking a look at this morning and this afternoon. So InForm feeds data into the DMW, which really is an alternate front end for the Life Sciences Data Hub. So first we'll start a little bit with study setup. So when you come into the Data Management Workbench, you come into your Home tab. And in your Home tab, you basically have a list of all the studies that you've set up. Now, this is a development environment, so there's not a great amount of information here. And then you pick the study you're going to work on. Now, in the Home tab, when you select a study, you actually can see what's the runtime, so loading of data, transforming of data, and validation checks. We're going to cover that in the second part of the presentation after we discuss how to set up a study. So let's go into setting up a study. So if the first thing I want to show is when I'm working with a study, what the study properties are. So I'm on the Home tab again, and if I click on Study Properties or I create a new study, it has a name. It has an indicator whether the study is a template study. So you can create example studies as templates so that when you create new studies, you can create them from a template rather than just creating them from the scratch. Whether it's active or not, list of therapeutic areas. This is a list that's customer-driven, and you can set that up as part of the administration. And then study size. The study size is really there for performance reasons, and I'm not going to go into the technical reason of how you would set up partitioning, but that's what the study size is for. In addition, as you're building out the study, it can go through a life cycle. So development, quality control, and production. We're really going to focus on the development mode for now. So you create the study, and then after setting up some administrative steps, you go into study configuration. And in study configuration, you have your clinical data models, your data transformations, and your validation checks. So in this particular study, we have 3 data models. We have InForm, and this is the data model that's been pulled across from InForm. We have a central lab data model. In this case, this is just some central lab file that's being loaded to data set. And then we have a downstream data model that really combines the lab data and it combines the InForm data together. Now, when I go into some of the transformations, I'm going to show you that typically you would have a much larger downstream model for a particular study. This is just for this specific use case example. So let's take a look at the InForm data model. The InForm data model is directly extracted from the InForm study itself. So if you see the tab here that talks about InForm configuration, you actually can go to this remote location, which is defined under administration. The focus of this talk will not be on administration. Then there's some account information, life cycle of the InForm study, where the web services are. So this essentially, and the URL. So this essentially is the area where you say, hey, what's the study that I'm going to grab? Right now, I have it suspended. If I had it suspended, I can then press Load Metadata, and then it goes into the InForm study, pulls out all the extract table structures, RD tables, and it creates them in here. So there's no need to manually synchronize the InForm study structure with the DMW structure. So if I click through these, so here's ConMeds, it's here. If I were to look at the ECG area here, that actually would correlate with the ECG area that you would see here in InForm. So basically, it automatically synchronizes between InForm metadata, between the DMW metadata. So once you have the actual model in place, you can load the data just by pressing this button, which will manually load the data. Or once you move the study into production, you can set up a frequency. And the frequency can be minutes. every 30 minutes. The way that Oracle has designed the frequency of loading the data into DMW is an incremental load. And it's incremental really down to the patient level and even beyond, so that you're only pulling small amounts of data rather than pulling the data into your DMW environment once a week or once every 2 weeks and doing reviews then. You literally can do this every few minutes and pull it across, so it's like a trickle feed. And I think that's a very important differentiator to how most people are doing their work today. So that's very interesting. Okay, so we have our InForm data model. We have the central lab data model, and the central lab data model is a variation of CDISC in this particular case. Now, because this is a file-based approach, we have this concept of file watchers. So depending on the validation, we have dev data, production data, test data, there are watchers have been set up in directories sitting on a server where you can just drop files. In this case, it's expecting a SAS file. Yep. So if a SAS data set is just dropped in this directory, it's using the underlying LSH technology to pull that data in. So part of setting up the metadata is where are these files going to be? And it can handle SAS data sets, it can handle SAS transport files, it can handle SAS seaport files, but it also can handle text files that include CSV, delimited files, etc. So it's really using the underlying specification. And as you can see right now, there have been it runs a bunch of checks. So we're gonna go into some of the tasks when we do the runtime. So once you've defined the models that you're interested in, you could always keep adding more models. You install the model. In the case of the manual or like central lab models, for InForm, when you bring the metadata across, it picks up the model automatically. And then we have a combined model. So it's very important to understand that you have these multi-step models, and the models interact with each other. And we'll talk in a minute about how the models interact with each other. So I'm going to switch to another study to talk a little bit about how models interact with each other. So just go over here, pick a different study. It just happens to have SDTM as one of its models. So if we go to study configuration, we can see not only does it have the InForm structures and the central lab structure, but we've got an SDTM model. So this SDTM model typically would come from the library. The library basically is a library of models. So you have two ways of standardizing in DMW. You can either have models have libraries, and you can have studies that have templates. So the library models are really metadata structure for tables or data models, and then templates would include validation checks, would include transformations between models. So if we actually look through this, it's kind of your standard SDTM. If you look at like the demography data set, which we're going to take a look at here, it's the standard SDTM model. So what we actually want to do here is how do we get data out of InForm here into this model, into the SDTM model. So that's the first example of a transformation. So there's this accordion tab here, transformation. And we have two target models. One is the cross-analysis and one SDTM. So this SDTM model is under version control, all the mapping. So there's mapping from source to target. So all the sources are InForm, and then here's our target table. So we have all our target tables here for SDTM. And we're to look at one of the target tables, such as DM. How do I get the data from InForm to the SDTM? So the first thing you do is you pick what your sources are. Yeah? And then when you have your sources, and in this case it's coming from DM, and death. So the death record and the DM record on the InForm side are going to be used to produce DM on the target. And the type of transformation we want is join. So we're going to join the death record to the DM record to produce an output. But you can see from this drop-down, you can union things together. Direct basically just means it's a straight one-to-one type mapping. There's a pivot, and there's an unpivot mapping. So this really allows you to do things like go from a findings or structure, if you've collected vital signs in horizontal structure, and then you want to make it normalized, you can use the pivot and pivot. And then there's custom mapping. So we're not going to go through all these in this particular session. We're just going to look at the join. It's the simplest one besides direct mapping. So once you've mapped, okay, I want this, and you press map, and then it shows up down below, and then you'd find another one, you'd press map, and it would show down below. You can then begin to build out your join clause. So you can basically go, okay, for table 1, I want to join it to table 2, and what basically you're saying is we want all demography records, and we want to join to death records, but we don't, if there's no death record, we still want to keep the demography records. And that's really what outer join does, these outer join flags. And then you have to put the criteria. In this case, it's by subject ID. Now, if you had a custom transformation for mapping, it would show here, but we're not going to review that right now. So now at a table level, you've said, okay, I've picked my sources and targets. Now I want to go in at a column level, and I actually want to build out the map. So if I select the column mapping icon, I'm then brought to this screen. Now the simplest type of maps are just one-to-one maps. Now, so for example, the subject ID here is really mapped to the subject ID. Let me just scroll down, down here. You just click the both and you say map. And you could even do a multi-pick and say map. And in that case, you actually have to build an expression. So if I were, for example, to look at race, you can see that for race, I've actually got several different columns, all combined here as sources. But the output is a single field. So when you have multiple inputs, or you want to do some sort of manipulation across multiple inputs to a single output, you use the expression builder. So the expression builder here, I'll click on that, will allow you to concatenate or to really use any function, and we're going to look at more advanced function in a minute, to actually bring together data at a column level on a function base. So you can do a one-to-one mapping. You can do a combined mapping, function-based mapping that basically has a single input with multiple inputs with any function in between there. And then you do a completely custom mapping, target table by target table. So once you have these mappings, you are then able to produce in a very traceable and repeatable way, and we'll look at the traceability a little bit later, exactly the source to target relationship from one model to another. There's also some efficiency functions such as automap, install, you can validate them. You can also say, okay, what's missing, what's not missing, in case you've left out certain fields. So you have quite a lot of different approaches on how you can do the mapping. For a 1-hour teleconference, I can't really go through all the features of the mapping utility, but I think you can see that it's fairly flexible. So that's how you set up mappings. So you can go from one model to another. So the next section I'm going to look at is the validation checks, and then I'll look and see if there are any questions that have collected up and take some time to answer them. So there are lots of different types of validation checks, but the ones that are most interesting to me are the ones that you actually can compare the data collected in your EDC system, in this case InForm, with the data that's collected outside of InForm. So I'm going to switch back to another study. It's not the old one. InForm Cardio, and take a look at its study configuration. So we're still just doing the setup here. So validation checks are a new object. It's DMW and do not exist in LSH up until this point. So this is interesting if you've been following the history of life sciences data hubs. It's a new object. So again, we have central lab, and then we have InForm. Those are the raw data. And then we have kind of a combined. Now, the way that this has been combined, we're going to take a look at very briefly. I actually skipped a step in data transformation. So if you just bear with me, I'm going to step away from data validation and go back to transformation and look at how these were combined. So in fact, for the P-lab table, we're taking the central lab data, which is just a data set that's been loaded, and we're taking the InForm data and we're combining them. And how are we combining them? Well, if I look at the map column, that is combined with a join, but it's an outer join. Oops, if I do that at the table level. Here's the join. Okay, click on this. Right, so if the subject ID and the visit ID are the same, we're actually saying the ECG record should have triggered, according to the protocol, that there was also a lab draw. So for every ECG record, we want to make sure that we've got a lab table. So we're combining the two, and we're doing an outer join. Now if we look at the column level mapping, it's exactly as you'd expect. It's mostly one-to-one mapping. I just wanted to point out one particular case. The actual high and low flag, and it's a little bit artificial, are coming from a function lookup, so a custom function lookup. So if we actually look at the expression, we see it's lab utils get low, and lab utils get high is the other one. So these functions, lab utils get low and lab utils get high, those are custom functions that have been built that are available to DMW. Now Oracle can't think of all the functions you want. As a result, they really haven't given you all the functions you want. But within the Life Sciences Data Hub, and now I'm going to switch to the LSH interface, within the Life Sciences Data Hub, you can actually create any type of custom function you want. So there is a domain that gets created within the Life Sciences Data Hub. Domains are just like folders, for those of you that are not familiar with the Life Sciences Data Hub. And within there, there's a DMW utils domain or folder. And then any shared function that has been moved to production is available. So in this case, the lab utils PL SQL program has been moved to production, and it is shared. So all the functions that are available in this lab utils program, so if I actually go to the source code and look at it, all of these functions, get low, get high, whatever, are available within DMW. So you really have the ability to build up a library of mapping functions that are completely unique to your environment, but still are available to the general team to actually grab and work with. So I just wanted to mention that about data transformation before I moved into validation checks. So setting up validation checks. So InForm has its own validation checks, but when we bring that data together, we are now want to run some validation checks on the combined data. Some of them are very, very simple. So these are just normal checks that say, okay, did someone mark this as an abnormal reading, but it's within the range? So let's just take a quick look at that. Very simple check. Okay, so you basically can say, okay, what are the sources for your validation check? In this case, there's only one source, it's PLab. And then these are your variables, and you can actually pick the columns that you want. There's no joins in this case. It's just from a single table that's already been combined. and then you put in a criteria. And there's a language for this criteria. It basically says that the lab NR indicator is abnormal, and that the result is actually correct. So the key here is that we're actually running an edit check on a table that's a derived table, and it's not a table that's a raw data table. So we're actually able to combine checks across sources. I'll take a look at one more of these. Cancel that. So if we look for no lab data exists, so let's look at that one, because we're going to follow up on that one in a bit. On no lab data exists, we actually are looking at the data visit and the visit information that happens to be from InForm, and we're looking at the test code. So if we look at the actual criteria, it basically says the test code is none. So one of the things we set up when we combine the data is that the test code, if we didn't have a lab reading from the central lab, but we did have an ECG reading, the test code was marked as none. That's part of the conditions of the outer join. So we can raise a discrepancy back to the lab that basically says, where is this test? And then potentially we could even raise a discrepancy back to the site as well. So you basically can get an arbitrarily set of complex validations. Those validations can exist on any of the data models, and then you can backtrace those to the original source. So you don't always have to write your edit checks directly on source. So that's a brief discussion of setup of the data models, the transformations, and the validation checks. Before I go into the runtime and the listings and discrepancy management, etc., I'm just going to pause for a moment and check to see what questions are out there, if any. So hopefully this unshares my desktop. There we go. Okay, it looks like I have a number of questions. If you just give me a moment, I'll read through them. Okay, so the first question is, how does DMW differ from other CTMS and CDMS such as ClinTrial and Oracle Clinical? Okay, that's an excellent question. So in some ways there is overlap to a clinical data management system. The difference is underneath the architecture of these clinical data management functions is an architecture for warehousing, analytics, and reporting. So because the Life Sciences Data Hub is under this architecture, the data coming from InForm is actually coming into a clinical warehouse that is fully integrated with SAS, has version control, has blinding, has all these functions that don't have a predefined data model. The data models can be anything and multi-stage. So if you're working with a ClinTrial and Oracle Clinical, you basically have one layer of data model and one layer of extract. And while you can do the validation checking in ClinTrial or Oracle Clinical, what you can't really do is multi-stage processing, multi-stage reporting for different consumers, have different architectures. So that's a very brief summary. I think it deserves a much longer discussion. How does DMW handle metadata changes mid-study, both from EDC and external data? So the way that it handles it, basically everything is under version control, and as new versions come through in development, then they go through a life cycle of development, QC, and production. So while you have your production study running, as the changes come through, the metadata changes, etc., those get worked through development, and only as you promote them through to quality control and production after you've tested changes, do you actually apply them to the production data and the production flow itself. The next question I'm seeing is, can this tool handle 100% SDTM mappings for very complicated logics? Yes, it can. And I think the way that you would handle for very complicated objects does come down to custom mappings. So the situation is, with the kind of mapping that I showed you, where you're basically doing one-to-one mapping or function lookup mapping, you could probably cover about 90–95%, depending on how rich your function library is. But there's always special cases. So very similar to how I showed you the custom functions, you can actually create completely custom programs and validate them, and then those custom programs can be used for that few percentage that the graphical mapper or the interactive mapper doesn't cover. So yes, it can cover 100%, but it's not magic. At the end, what I have found in my experience is that there's always a few little tweaks, few little special programs that need to be handled in order to move forward. And then how do you maintain traceability with a custom mapping? So we can maintain traceability with function-based mappings. Variable level traceability across a pure custom mapping is not really possible, because underneath, inside that code, you don't know if aggregation is occurring or something like that. But if you don't use the custom mappings, then in fact you get full traceability, and we're about to take a look at some of those features. And a bunch more questions are going to pop up, but since I'm only about halfway done with the presentation and I have 20 minutes left, what I'm going to do is I'm going to go back to the presentation, and then if any time is left at the end, I will go through and answer the remaining questions. But thank you for all the questions. I really appreciate it. All right, so I'll share my desktop again, and now we're back into Data Management Workbench. Okay, so I've got my study set up. I'm working through it, and I want to start loading data. So I've set up, let's say, I manually loaded data through the screen I showed you previously under the data models, and I've dropped some files into, for the central lab, into this directory. So here's an example. On the 23rd of January, someone dropped a file into the directory, and I'll get something like a result. So for example, I get an output file and I get a log file. This is the same LSH functionality for those of you that are familiar with LSH. It was a SAS data set. So you end up with a SAS log. And basically, you can see this is a SAS log that basically talks about, this is the output. Let me close that one. And then if I actually look at the results here, one of these two, and this is the LSH or DMW log. So you end up with a SAS log and a DMW log. If it's a text file, you would end up with a SQL loader file there. Okay. So basically, this is just a history of the loads that have occurred. So this study's been loaded once as the metadata, and twice we loaded the data. If you have it loading every few minutes, you would get lots and lots of lists here. The study is currently in development, so it's not using automatic loads yet. On the transformation side, you get a history of the transformations and when they've been run, and it's really by model. And here we can see we ran the PLAB model once. So basically, this is all the runtime information, and you can, if you have the rights to schedule the job, this is just a place where you monitor the job. And similarly, for the, let's say, the InForm cross-analysis, you get the record of your the runs here. So that's really the first thing. Second thing I want to look at is data listings. So I click on listings, and depending on which data model you want to look at, you get those listings. So all the tables here are here for the listings. So for example, if I want to look at a particular listing or a particular default table, just click on it, and I actually am looking at the data that's been loaded. So in this case, you can see there's 28. You can go through it. It's pretty straightforward for sorting. Let's say I wanted to sort by the subject ID. You just do these little triangles, and it sorts sorts ascending or descending. If you want to actually search for particular records, you click the Find button, and you get all the fields, and you can search on any of those fields. So for example, if I was interested in Site 14, I just put Site 14 here, and let's say search. And that should filter by Site 14. Okay, that's not what I expected. Let's try that again. I must have made a mistake. Because it's the wrong field. It's actually called site mnemonic, if I remember correctly. Okay, and here you can see the records for Site 14. So it's pretty simple browser. This is not Spotfire. This is not OBIE, but it really does give you information. If there are discrepancies on a particular record, you do get to see those discrepancies. So if I tab through here, I can see the little yellow flag there, and it's saying, okay, congestive heart failure. I can tell there's a discrepancy. I can say show discrepancy. So it goes right down to the cell level, and it says please complete the ConMed form prior current medications. So this actually came from InForm. We're going to look at discrepancies in a moment. And there's also a concept of flags. Currently there are no flags on these records. I'd have to find some records with flags. So you don't need to define any of this. This all comes from the data model. Similarly, we could look at our join data. So that's the data that came from both central lab combined with the InForm data, where the data visit is coming from InForm, and if the lab data is actually loaded, it's coming from there. And you can see that we've got various discrepancies here. If I say show discrepancies on this one, you can say no lab data exists. And this really is the validation check that we saw a few minutes ago. So it comes right down to the cell level. Now, one of the questions that you might ask is about traceability, because I think this is very important. So here I've got this combined data set that has date of visit and a few other fields from InForm, but the actual lab data is coming from the central lab data. So in this case, if I click on this cell and I say trace data lineage, it goes back through the functions, and we just expand that, and you can see that it's coming. It's in the field itself is this plab1.dov. That's the field we've highlighted, but it's actually traced back to InForm egsent.dov. So it's coming from the day of visit in the egsent field. So you do have this full traceability to see where it came from. So that, I think, is a very important feature, because similarly, if I went and looked at one of the ones that actually had lab data, let's just say this protein, and I say trace data lineage, this now is, you can see, coming from the central lab file. So even though we've joined data, we actually can see the data lineage of exactly where the data came from. Did it come from the central lab file, or did it come from the InForm file in this case? So, or the InForm, there's no file, the InForm database in this case. In addition to these type of simple listings, you also can create custom listings. Now, I haven't created any custom listings, but it's a fairly simple concept. You just press the plus sign. I'm not going to take too much time here. You give it a name, and you're going to have to actually pick what models. Oops. Okay. So I'm not going to go through that now, but I've seen some of these custom listings work where basically you pick the source. So in this case, the source could be plab1, but I might be working in another model. Let's just cancel this one. Let's move over to the InForm model. Cancel. Sure you want to cancel? Okay. Great. Let's do it this way. That's the easy way. Let's go to the InForm model and create a custom listing there. Pick my sources. Seems to be a bit confused. View source. All right, we're going to skip this for now, and we'll come back to it if we have time later. But basically, you can go through and you can create joins, you can create pivots, all the things you really saw in the mapper. Basically, you can create essentially just a pass-through view. And then the last type of listing really is the what's called the validation listings. So you may actually want to see a listing of only data that failed a particular validation check. So for example, if I just want to see only the stuff where no lab data exists, I can say, okay, that's it. So rather than going through everything, I'm really just focusing on this. And the advantage of this is when we go to export this stuff, you can just send all this stuff straight to the lab. It's already pre-filtered and it's ready to go. And we know that the lab could get this list. Now, one of the other things I wanted to show you is the ability to create discrepancies on the source system. So let me go back out, give it a bit of a reset there, click on Listings, select InForm. Let's go look at our AE table. And let me filter it, since I know I've got a, all right, let's go to the site 014. Scroll down, do a search, so I can just restrict my records here. Did I do the same mistake that I did last time? I believe I did. It's site mnemonic. Not site. Do a search. Okay, so here's 014. So these are the adverse events that exist for this particular site. I'm just scrolling through, and let's say I'm doing my data review, and I'm like, uh-oh, this is wrong. I mean, this is fine. There's no medical problem with this, but I'm just using that as an example. What I can actually do is I can create a discrepancy as part of my review process here. And I can say something like, please rephrase. So this is particularly useful if you have a coding system that's outside of InForm and you just want to code the data in DMW and then you want to send some things back to the site. So let's say they want you to split terms or something like that. Okay, and just, I'm going to say okay. All right, so now there's a discrepancy in DMW, and if I actually say go to discrepancy, let me highlight it first, go to discrepancies, it'll jump me across to this discrepancy itself. So now I can add comments to this discrepancy. I can do whatever, whatever I want. But what's interesting is I can actually click on this set to InForm. So first let me edit the discrepancy. I want to make it an active discrepancy. Send to InForm. State. No, I want to change the state. Okay, well let's see what happens. Reason mandatory. Okay, it's thinking. Uh-oh. And of course, we get an error. So let's actually not do that right now. This is the kind of thing that works extremely well when you're practicing. So let me just refresh this. Here, double click it. All right, now I've upset it. Let's continue back through the discrepancies, and we'll come back to that in a moment. So on the discrepancy tab, you get basically all the discrepancies that exist both in DMW and in InForm. So if I click on From InForm, you get all of the discrepancies that come from InForm. So part of the synchronization when the data comes across is that you can look at the discrepancies from InForm along with the discrepancies that are not in InForm. So weight is not within specified range. You can go here and see this. This is an InForm discrepancy. It came from InForm. You can say display full record, and it actually gives you all the data associated with that record for that discrepancy. And then you can actually add comments to that discrepancy. So those are InForm discrepancies. But then if we actually look at the manual discrepancies, these are discrepancies that primarily have been created inside DMW. You can see those together. So you have lots of ways to filter those discrepancies and manage those discrepancies. So you can restrict by site. You can say what model you want, etc. And you can actually manage those discrepancies like you would in a clinical data management system. So you really have the ability to filter and manage those discrepancies together. So unfortunately, I'm not sure why that discrepancy didn't go across. I was going to actually walk you through in InForm the actual crossing of those discrepancies. I have another subject that I did this on the other day, and I can show you that in a moment. But before I do that, let's just finish this discussion. So one of the things that you can do, and it's particularly useful for listings and custom listings or non-custom listings, is you can export the data. Now, you can do a very simple export. So let's just say I wanted to take this medical history or physical exam table, and I want to export it. So there's a very simple way to export it. I can say export it all to Excel, and then it just takes that file and brings it up in Excel. So this is an example. So you can work with it very quickly. Similarly, you could export it to a CSV. It basically, works the same way. But what's much more important is that if you go over to the Life Sciences Data Hub, you have the ability to work with this data downstream. So you can do things like create a business area. So what happens, I'm now switching over to the Life Sciences Data Hub user interface. And in the Life Sciences Data Hub user interface, all your therapeutic areas are there that you've set up. In this case, we'll look at cardiology. Then each one of your studies is there. In this case, we'll look at the InForm cardio study. And then for each one of your life cycles, you've got dev, production, and QC. And we're really focusing on dev. These names are not really meaningful. In fact, Oracle has chosen to make them unique by giving them some internal ID, but the description helps give you an idea of where the data is. So the InForm data itself is here. The metrics data is going to be in here. For each one of your data models, you always have a container as well. And then you've got some stuff about validation programs and some other programs. But let's take a look at the InForm work area. So if I click on InForm, what you actually see is that all the tables are actually tables inside the Life Sciences Data Hub, as well as the query information, flag information. So if I were to look at that same data here inside the Life Sciences Data Hub, this is the same data that we were seeing through the listings. This is very important because the Life Sciences Data Hub, downstream from the Life Sciences Data Hub, any of these work areas, you can create any programs. They can be PL/SQL programs, SAS programs, Informatica programs, anything that you want. On top of that, you can create what's called a business area. Now, this really is not a discussion about Life Sciences Data Hub, but the business area allows you to use tools like Spotfire, business objects, JReview, right on top of this data. And it's not a separate copy of the data. So as your data is flowing through from InForm through those data models, you can actually take your standard data model and then layer a tool like Spotfire or JReview on top of that and actually use that for your review process. And you're not making an extra copy of the data. The same traceability applies across the board, whether it be inside LSH or whether it be inside DMW. So I'm seeing I have approximately 4 minutes left on my clock, so I'm going to switch over to questions. Obviously, this is a very deep topic, and we could talk about it much more than an hour. So with that, I'll switch back to questions and see if I can answer some of them. Okay. Yes. Data cleaning due in DMW. How do you flow back to the InForm transaction base? Okay. Transaction database. So that's what didn't work in the example, although I definitely had it working this morning. Basically, it's done through web services. So as soon as you say send to InForm, it calls an InForm web service, and it actually synchronizes it back to InForm. Next time data comes, you load the data from InForm, it also loads all the discrepancy information. So you have the full control loop. So the data cleaning goes back and forth. Basically, you go through and you mark discrepancies as sent to InForm, and it's tagged against the variable that you're working against. The next question has, can we use DMW when using Oracle Clinical as EDC tool? So this current release really only accepts files and InForm. So we do not, Oracle does not have the connector for OCRDC or RAVE or anything else. It really is focused on InForm. My understanding is future releases, they are planning on adding some of that functionality, But since we're BioPharm, we can't really state what Oracle is going to do. But currently it really only supports InForm and files as its inputs. Next question is, do you start building your trial DMW after your InForm trial is built, or is it done in parallel? In general, DMW will lag behind InForm, so while you're still basically constructing it, you wouldn't do it immediately. But there's no reason it couldn't lag, say, a few days or a week behind. It's certainly not well behind, but you want to actually get some stability in your structures in InForm before you pull it into DMW. It's really the best practice on how to handle that. The question I have is, when creating discrepancy on a listing, can you send it directly to InForm, or do you have to go to discrepancies? My experience is that you have to go to the discrepancy and send it to InForm, but I think in the user documentation it says you can send it directly to InForm. I haven't actually gotten that to work. I think in theory you can send it directly to InForm, but usually my experience to make it successful, you review the discrepancy and then you send it to InForm. So that may be a bug, or it may just be my lack of knowledge. Okay. The next question I have is there any option for graphs in DMW in addition to reports? So the list functionality is limited as you've seen it. If you want more advanced graphing with a tool like OBIEE or Spotfire or JReview, those same listings through the LSH interface are available to all of those tools. So you do lose, obviously, in Spotfire and JReview the ability to backpropagate discrepancies. But for a really nice interface, right now I would say use a tool like Oracle Business Intelligence or something like that. I have a couple more questions. I do want to take a minute to wrap up, though. When a discrepancy is created in DMW, how will it be routed back to InForm? So I think I answered that one already. It's done through the InForm Web Services. And then the next one is, can we consider DMW as a metadata management tool, plus data cleaning and discrepancy management tool? Yeah, that primarily is the purpose. LSH underneath is a metadata management tool. This is an alternate interface for that. Because you can have models and queries and they're kept under version control, you can actually use this as a metadata management tool. I think the actual cycle of metadata management, it's not explicitly handling the whole approval life cycle for a new variable being added into a model as a workflow, but it does all the underlying version control and metadata management. And in the LSH side, you actually can write comparator reports that say, how does my standard model compare with this other standard model? Kind of running out of time now, so I do want to wrap up. I wanted to thank everybody for joining. I do really appreciate it. BioPharm is knowledgeable on DMW. It's early days for you. We work very closely with Oracle to really become experts in this area. And please feel free to reach out to us and ask questions. If you think you're interested, if you have questions about this, LSH, or any clinical warehousing and analytics applications, we'd be more than happy to answer your questions. So with that, I think I'll hand back to Eugene, and he can wrap up the webinar. Thank you again.
Great. Thanks, Mike. So as a reminder, we'll be sending out a recording of the webinar as well as a PDF version of the slides within the next 24 hours. You can also go to biopharm.com to access the recording and presentation. We want to thank you for your participation and hope that the information Mike provided today was helpful. And as always, feel free to register for our other upcoming webinars, which you can find on our website. Thank you so much and have a great rest of the day and evening.